Hello everyone. Today we're going to go over estimated time of arrival and how we figure out when we're going to arrive in a certain place. If you're following along, we are still on job sheet 2, TAC 5, TAC 2. This is what our ETA problems will look like. You can tell it's an ETA problem because at the very last line we'll ask you what your estimated zone time of arrival is. We'll also always give you where you are departing from. In this case, you are going from New York and you are headed to San Francisco, California. Other given information includes when you will leave your departure city. So in this case, you leave New York at 0500 zone time on 16 May. We will also give you the latitude and longitude of your departure and your arrival city so that you can calculate your zone description. Next up, we'll give you your speed of advance, your SOA. In this case, it's 13.5 knots. You can find that in your outboard or whichever speed is most fuel efficient for you. We'll also give you the distance that you have to travel. You'll be able to find that in Pub 151, or you can do the distance calculator yourself. We will always give that to you. In this case, the distance is 5,132 nautical miles. This problem has a twist. So we have you stopping for a NATO exercise off of Cologne that'll take you an extra 32 hours. And then we also say that your transit of the Panama Canal will take an extra 14 hours. So you have to budget in those extra hours because on Navy ships we rarely go just from point A to point B. Usually we have something else to do, whether it's a certification exercise or a RAS or something like that. And as NAVs and ANAVs, we have to take that into account. And the last thing we give you is the tolerance. We give you plus or minus 15 minutes because as NAVs and ANAVs, we want you to be on time and we want you to be precise. This is just one way to do an ETA problem, and we've seen quite a few in SurfNav with our students. We think this is the easiest way because it helps to keep everything organized, but if you have a different way, we'd love to see it. So please show us. For our way, we start with taking our zone time of departure. In this case, we are leaving New York at 0500 zone time on 16 May. And we will convert that departure zone time into GMT, Greenwich Mean Time. This will make the match much easier for us because at least in the planning phase, we don't need to worry about when we will shift time zones. We'll worry about that when we're actually underway. This way, since we're making voyages of thousands of miles, convert it into GMT, do your math, and then convert it back into zone time. Our next step is to do our time, speed, distance calculations. Basically, we need to know how long it'll take us to get from point A to point B. We just looked at how to do that in the last video, so if you need any review, go back to that video and take a look so you can just remember what units we use and when we divide and multiply. Our third step is to take the transit time that we determined in step 2 and add it to our departure time in GMT. Once we determine that, then we can go on to our fourth step. We will have our GMT of arrival, and we need to convert that arrival GMT into zone time so that we can tell the pilot, hey, we'll actually show up at our destination at this time, zone time. And those are the 4 steps that you can use for every ETA problem. Let's jump in and try one out. If you're following along, you can go to job sheet 2, TAC 5, TAC 2 in the training guide, and we'll be completing question number 1. In this example, you'll be going from New York City to San Francisco, California. And before we jump in, let's take a look conceptually on a map of where we're going and what our voyage will look like. Here's a map of North and Central America. So we'll be traveling from New York City on the East Coast, and we'll be traveling to San Francisco, California on the West Coast. And our voyage will look something like this. We will start in New York, travel south, go through the Panama Canal, then head back north, and finally arrive in San Francisco. When you go into Pub 151, and you just look at that number, that's just a number. We want you to visualize what you're doing and where you're going. In this problem, we have you doing a NATO exercise off of the coast of Cologne, Panama, down in the south. You will spend an extra 32 hours completing that, so you won't actually be transiting to San Francisco at that time, so you just have to add 32 hours. And the same concept applies when you transit the Panama Canal. You will not actually be doing your SOA of 13.5 knots. You'll be going much slower because you'll be going through the locks. So you just have to add an extra 14 hours onto your transit time so that you don't show up late. So this is conceptually what we're doing. We'll jump into the calculations now, but we just want you to see the real-world implications of what you're calculating. Going back to our problem, we are going from New York to San Francisco. Our first step is to take our zone time of departure, in this case 0500, zone time on 16 May, and we need to convert that into Greenwich Mean Time, GMT. So we'll write down our time of departure in zone time, and you can do the same if you're following along in your notebook. And make sure when we put any time, we have something after it. So in this case, zone time. We'll also accept ZD plus or minus whatever, or alpha, bravo, delta, any of those time zone alphabet indicators. Basically, whenever you have a time, you need something after to tell us what type of time you're keeping. And it will really help you to keep all of your numbers in order as well. Let's start off by finding the zone description of our departure. So in New York, we give you the longitude. So it's 074 degrees, 1 minute west. So we'll bring that down. And we need to divide that by 15 degrees to figure out our zone description. However, we can't put this number into a calculator because it's not a full number. So we need to take our minutes, 01 minutes, and convert it into degrees. So we'll take our minutes divided by 60, and we get 0.017 degrees. Now we can take our 1 minute of longitude and we can replace that with 0.017 degrees. And I'm actually just going to round that to 0.02 degrees. We don't need to be that exact. We can round to the nearest hundredth. So now we can put this number into a calculator, 74.02 degrees. So we'll divide that by 15 degrees because each time zone is made up of 15 degrees, and we're looking for a time zone, and we get 4.93. You probably got a slightly different number in your calculator. You can see that I rounded it to 4.93, just like I rounded the 0.017 to 0.02. In navigation, you rarely need to be more precise than rounding to the nearest hundredth. So just keep it at the hundredth. And as we learned in our nautical time lessons, our zone descriptions need to be round numbers. So we'll take 4.93 and we'll round that to the nearest whole number, which is 5. So our zone description is 5. Now we need to figure out whether it's plus or minus. So we'll take a look at our longitude that we give you. We're in the Western Hemisphere, so it's plus. Now we know that our zone description is ZD plus 5. So we know that we are going from L to Z, local to Zulu, so we're going to let it be that plus 5. We're just going to add 5 hours. So we take our zone time, and we're going to add 5 hours and 0 minutes. And we'll do the math. We'll do it with you. So 0 plus 0 is 0, 0 plus 0 is 0, 5 plus 5 is 10. So carry the 1, 1 plus 0 plus 0 is 1. So we get 1000, and that's in GMT because we applied our zone description, and it is on 16 May 2017. Make sure we specify that it is GMT. We just converted from zone time to GMT, so that's very important. And that's our first step. We just converted the departure zone time into GMT. Now it's time to do our time, speed, distance calculations to figure out how long it'll take us to get from New York to San Francisco. First off, we will draw our handy time, speed, distance triangle that we learned about in a time, speed, distance video. Make sure that distance is always on top, and then speed and time are on the bottom. In the problem, we give you the distance. Distance is 5,132 nautical miles, so we have our distance. Check. We also tell you the speed. We estimate your speed of advance to be 13.5 knots. So now we have your speed as well. Check. And we are looking for your time. One thing to remember, since we're looking for time, you do need to add in the 32 hours for the NATO exercise, as well as 14 hours for the Panama Canal transit. Looking at our time, speed, distance triangle, we have distance and speed. We're looking for time. So we treat it like a fraction. We take our distance and we divide it by speed in order to get our time. So we'll take our distance, 5,132 nautical miles, and we'll divide that by our speed, which is 13.5 knots. And to save us in the future, I'm going to write that as nautical miles per hour, because 1 knot is 1 nautical mile per hour. We punch that into our calculator, and we get 380.15. And as you can see, I had rounded that to the nearest hundredth as well. We'll take a look at our units. We have nautical miles on top. We also have nautical miles per hour on the bottom. So the nautical miles will cancel out, and we'll be left with just hours. That's why it helped to say that 1 knot was a nautical mile per hour. So it will take us a total of 380.15 hours to get from New York to San Francisco. Now we need to take this number and we need to convert it into days, hours, and minutes, because it'll make the math much easier for us and make us less prone to error. Now we will clean this up a little bit. We'll take our 380.15 hours, we'll move it over here to the left, and we need to convert that into days. And we know that there are 24 hours in one day, so we'll take all of our hours, 380.15, and we'll divide it by 24 hours, and that'll convert it into days. Punch it into our calculator, and we get 15.84 days. We just found out that another way to say 380.15 hours is 15.84 days. So now on our piece of paper, we'll write down 15 days in the corner, and then in our calculator, we'll subtract 15 from that number we got, and we're left with just 0.84 days. Now we need to convert that into hours. So we take 0.84 days, and we multiply it by 24 hours, because there are 24 hours in one day, and we get 20.14 hours. So we just found out that another way to say 0.84 days is 20.14 hours. We'll take that 20 hours, we'll move it next to the days that we calculated earlier, so 15 days and 20 hours. And our calculator will subtract 20 hours, and we'll be left with 0.14 hours, and now we need to convert that into minutes. So we take 0.14 hours, multiply it by 60, because there are 60 minutes in every hour. We'll punch that into our calculator, and we get 8.88, and that's in minutes. And we can round that to 9 minutes, because 0.88 minutes on a long journey, we're not concerned about seconds. We are concerned about minutes, though. So we'll bring that 9 minutes down next to our 15 days and 20 hours. And that's how long it'll take us to transit from New York to San Francisco. However, we do need to remember that we're not just going from point A to point B. We have a NATO exercise and a Panama Canal transit. So we need to account for the 32 hours for the NATO exercise and the 14 hours for the Panama Canal transit. So let's add those two, 32 hours for the NATO exercise plus the 14 hours for the Panama Canal transit. Add those together, and we get 46 hours. So we need to add 46 total hours to our transit time. Now, for this step, you can either add those 46 hours in the earlier step we did, when we still had 380.15 hours, or you can add in this step. Whichever way works, as long as you get the right answer. We'll make it a little easier by converting that into days and hours. So we'll subtract 24 hours from one day. We get 22 hours. And since we subtracted 24 hours, we need to add that back in. We'll do that by adding a day. So another way to say 46 hours is 1 day and 22 hours. Now we need to add that to our total transit time. So we'll take 15 days, 20 hours, and 9 minutes. We'll add it. Let's see what we get. So we get 9 minutes. We get 42 hours. And we get 16 days. Let's clean it up. We'll move it up here as well. There we go. Now you can't have 42 hours in one day, so we'll have to subtract 24 hours from there. So we'll subtract 1 day's worth of hours from there, and we'll add a day onto the days. So add a day there, subtract a day there, so it equals out. So the total time it'll take is 9 minutes. 42 minus 24 is 18 hours, and 16 plus 1 is 17 days. So it'll take us total 17 days, 18 hours, and 9 minutes to go from New York to San Francisco, which is a distance of 5,132 nautical miles at a speed of 13.5 knots, in addition to the 32 hours for the NATO exercise and the 14 hours for the Panama Canal transit. That is the final answer for step 2. It's up to you whether you want to add those 46 hours for the NATO exercise of Panama Canal at this step or in the earlier step when you have 380.15 hours. It is totally up to you. So that's step 2. On to step 3, we'll add our transit time to our departure GMT, which is from step 1, we calculated our departure time in GMT. So we're leaving at 1000 GMT on 16 May 2017. And now we'll add our transit time. So we'll add 17 days, 18 hours, and 9 minutes. And the easiest way that I find to do it is we take our hours and minutes and we move them over here. So we'll add 18 hours and 9 minutes to our time, and then we'll take our days and we'll move it under the day of the month. So we'll add 17 days there. We'll start by adding our hours. So we'll take 1000 GMT and we'll add 18 hours and 9 minutes. 0 plus 9 is 9, 0 plus 0 is 0, 0 plus 8 is 8, 1 plus 1 is 2. So we will arrive at 2809 GMT. Uh-oh. 2809 is not an actual time, so we've progressed into the next day. So what we need to do is we need to subtract 24 hours. So we'll take a day, we'll subtract 1 day over here, we'll add a day to the actual days so that it cancels out. We'll do a little math for our hours. So 2809 minus 24, 9 minus 0 is 9, 0 minus 0 is 0, 8 minus 4 is 4, 2 minus 2 is 0. So our new time is 0409 GMT on the next day, which is why we added a day over here. Next up, we need to add our days. So we'll add 16 plus 17 plus 1. 6 plus 7 is 13 plus 1 is 14. So there's a 4. We'll carry the 1. So 1 plus 1 plus 1 is 3. So we get 3. So we'll end up arriving on 34 May 2017. Uh-oh. 34 May is not an actual date, so that means we progress into the next month because there are only 31 days in May. So we'll take 34 and we'll subtract 31 because there are 31 days in May, and we get 3, and we'll advance to the next month, which is June. So 34 May is also known as 3 June 2017. So here is our answer. We will arrive in San Francisco at 0409 GMT on 3 June 2017. Our last step is to take that arrival GMT and convert it back into zone time. We're not going to tell the pilot in San Francisco, oh, I'll meet you at 0409 GMT. No, we need to tell them what time zone time will show up. So that is our last step. This is very similar to step 1. The only difference is we'll take the zone time of our destination. So let's write in our arrival GMT, 0409 GMT on 3 June 2017. And now we'll take a look at the longitude of our destination, San Francisco. Longitude is 122 degrees, 24 minutes west. So now we need to find the zone description of it. So in order to find the zone description, we'll take 122 degrees, 24 minutes west. We can't put that number into our calculator, so we have to convert it into full degrees. So we'll take 24 minutes divided by 60, and we get 0.4 degrees. So we'll replace the 24 minutes with 0.4 degrees, so our longitude is 122.4 degrees west. And now we can take this number and put it into a calculator. Now to figure out the zone descriptor of San Francisco, our destination, we need to take our longitude and we'll divide that by 15 degrees because each time zone is made up of 15 degrees. We put that into our calculator and we get 8.16. It's a zone description, so we know it needs to be a whole number, so we'll round that down to a full number, 8. And then we look at our longitude of San Francisco. It's in the Western Hemisphere, so our zone description will be plus. And this is a long way to do it. Once you start to do enough of these, you'll just start to memorize the central meridians. In this case, the central meridian is 120 degrees west, so we know that our zone description will be ZD plus 8. So keep doing these until you're comfortable enough to just know the central meridians, and then you don't even need to do the math. You just know what the zone description is. So our zone description is plus 8. We'll clean this up. And in this case, we're going from Z to L. So we're going to reverse the spell. We're going from Zulu to local. So this plus 8 becomes a minus 8, and we will subtract 8 hours. So take our GMT, 0409, subtract 8 hours and 0 minutes. And we cannot subtract 8 hours from 4 hours because we get a negative number. So we need to do a little math. What we'll do is we'll take a day from here and we'll add it over here. So we'll add 24 hours to the time and subtract 1 day from 3 June and it becomes 2 June. So since we subtracted a day, then we can, from here, then we can add 24 hours onto the time. So we'll take 0409 plus 24 hours, and that becomes 2809. That's not an actual number, but it will make the math easier. So let's do the math. 9 minus 0 is 9. 0 minus 0 is 0. 8 minus 8 is 0. 2 minus 0 is 2. So it's 2009 zone time. And then we take the days from over here and we bring them down. So we will arrive at 2009 zone time on 2 June 2017. And that is the final answer. That is our estimated time of arrival at San Francisco. And that's how we calculate ETA. So if you have any questions, please let us know, and we'd love to help you out.